Hello students, today we are going to start here Kepler's law. Kepler's laws. Now listen here first story. Johannes Kepler was a German astronomer and mathematician. He stated three laws describing planetary motion. And these are known as Kepler's laws. So now see here Kepler's first law, second law and third law. Before starting this chapter, I am taking here first basic point, that is ellipse. What do you mean by ellipse? What do you mean by ellipse? Ellipse. Ellipse means here, when we cut cone, suppose it is cone, okay? When we cut cone in an inclined plane, and figure is formed here, are called ellipse. It's clear. And in that ellipse having a 2 points, that is called foci or focus. Now see here, these are the ellipse. Okay, these are the ellipse, and there this point and these points are called focus. Okay, the distance between of the each point to the edges of the ellipse, okay, are distance equal. That means here, suppose it is f1 and it is f2. Point is here A, here point is B. That means here f1a, bf1 is equal to af2. The distance between from any point, any focus to the points of the edges are equal. It's clear that about the ellipse. Now start here Kepler's laws. It is a basic point of the ellipse, and that ellipse are used in a Kepler's law. The Kepler said that first laws here, the orbit of planet is an ellipse with the sun at the one of the foci. The orbit of planets. First of all, listen here, orbit. Suppose it is elliptical orbit. It is elliptical orbit. Give attention careful now, student here. Okay, it is elliptical orbit, and suppose it is planets A. Give the name here. Suppose A. That one is a planets, and there are sun. Okay, it is sun. The Kepler said that here, when planets is revolve in an elliptical orbit and sun shows here one of the foci. We know, student, we know that here elliptical orbit is two foci, right? Two foci. The sun shows is one of the foci, right? The planets revolve in a elliptical orbit. Orbit means here rotation, revolving of the path are called orbit. It's clear, the first law. The orbit of planet is an ellipse. The orbit of planet is an ellipse with the sun at the one of the foci. This law is also known as law of orbit. Law of orbit. First law, that is law of orbit, also known as, okay. There is clear the concept. When planets revolve around the sun in an elliptical orbit and sun shows at the one of the foci are called Kepler's first law. It's clear? Now see here second law. Kepler's second law. Kepler's second law. In that laws, the line joining the planets, sun sweep equal areas in equal intervals of time. The student, listen here in that figure. It is elliptical orbit, right? It is elliptical orbit, and there are sun present at the one of the foci. It is sun, and there are given line joining. Suppose here planets A. It is planets, okay, at point A. We have to consider now, okay, and line joining from sun to point A, sun to planet. So in this laws, the line joining planet and sun sweep. If the planet is swept from A to point B, slowly planets go from point C to point D, point C to point D, point C to point D. The line joining the planets sun sweep equal areas. Which areas? The covered areas, this one area A to B, are equal to the areas CD. That means here area AB is equal to area CD. It's clear? If suppose you have to cover planets covered your covered areas from A to B in a 1 hours. 1 hour. Similarly, the planets goes at the point C and it also covered the distance from C to D, covered the area from C to D in a 1 hour. That means here the line joining the planets and the sun sweep equal areas in equal interval of time. Equal areas in equal interval of time. It's clear? Kepler's second law. Thereafter, now see here Kepler's third law. Kepler's third law. Kepler's third law. Kepler's third law, the square of its period of revolution. The square of its period of revolution around the sun is directly proportional to the cube of the mean distance of planet from the sun. Students, give attention here. Kepler's third law. Square of period of revolution. First of all, listen. Period of revolution. Period of revolution means here, now see in that figure, planets is revolve around the sun in a unit time. The one rotation in a unit time are called period of revolution. It's clear? And that period of revolution is denoted by T. It's clear? The square of period of revolution, that means T square. Around the sun is directly proportional shown in that symbol alpha, is cube of the mean distance from the sun to planet. Okay, sun to planet is denoted by R. The cube of the mean distance, that is cube. Mean distance, that is average distance from sun to A, from sun to C, from sun to D. Okay, cube of the mean distance, that is average distance of planet of the sun from the sun, are called Kepler's third law. It's clear? Student, listen again. The square of period of revolution, that means here the one times revolution, again times revolution, is square of the revolution around the sun is directly proportional divided by alpha to the cube of the mean distance from the planet A, planet C, D. Okay, so cube distance of the planets are called Kepler's third law. So one more thing here, listen here, basic point. Proportional, directly proportional means here. Suppose, see here, every planets revolve around the sun. Now see here in that figure, every planets revolve around the sun. Suppose sun is there, it is sun in the center, okay, and planets revolve around the sun. It is first planet. Another planets revolve this one. The distance, it is a line drawn from the planet to sun. It is distance and time. Listen carefully. If the planets are closer to the sun, the revolution is revolution of time is less. But distance is take here. Another planet, suppose here. That one. This planet is revolve around the sun also. But now see here, the distance here increase, therefore the time also increase of the revolution. That means here, directly proportional means here, t square. T is depend on a distance. Time is depend on a distance. Time and depend is not equal. It's clear? Or distance or time is not equal. If the time is increases, the distance also increases. If the distance is increases, the time also increases. It's clear? Give attention in that figure. See again the planets revolve. This one planets revolve around the sun. It is the sun. Okay. The distance between the first planet is less than the another planets, right? The distance is increases here another planet. The time also revolution of is increases. Is clear? So that is called here directly proportional. In third law, square of the revolution, cube of the mean distance. Okay, t is directly proportional to r. If t square, that means here r cube. That means here r cube. That is shown in the Keplers shown in that third law. It's clear that basic point. So again now listen at Kepler's third law. The square of period of revolution around the sun is directly proportional to the cube of the mean distance of planet from the sun. So the mathematical expression now written here, t square is directly proportional r cube. So now again listen here, t is not equal to r cube. So how can we show equal to? The t square is equal to, take a constant value, any constant value, take any alphabet k r cube. T is square is equals to k r cube. Or we can write here also, t upon r cube is equal to k. T square upon r cube is equal to k. It is a mathematical expression of Kepler's third law. So students, listen carefully now. This one, Kepler's first law, that is orbit law. The orbit of planet is an ellipse with the sun at one of the foci. Then second law, the line joining the planets and the sun sweep equal areas in equal interval of time. Then third law, the square of its period of revolution around the sun directly proportional to the cube of the mean distance of planet from the sun. It's okay? It's clear that concept of the Kepler's law? Okay, it is a very important point for our life also and examination also. Okay, there should be asked the 3 marks question in board exam. Okay, now stop here.